Scientific method is about a decision-making process. It's about evaluating things and then coming up with a decision about it, the way that things can be analyzed. I believe that scientists have to make decisions based on scientific method. First part we have to understand is that there is a difference between these two words, which are truth and fact. Truth is based on a belief system. If you believe it, it is true. If you don't believe it, you will say it's not true. We get into a lot of arguments about what is true and what is not true, and a lot of times we come up with the concept we can agree to disagree. We have fact. Fact is repeatable, which means you do it again, it comes out the same way. And when it comes out the same way, it is not something we can agree to disagree on. Whether or not you believe in gravity, whether or not you understand what gravity is, it doesn't matter because it is a fact. It works in a certain way. And a lot of people confuse the two. And when you confuse the two, it becomes problematic. Scientists need to deal with fact. It's that simple. You have to deal with fact because fact is repeatable. Here's your question. Which weighs more, a pound of feathers or a pound of gold? You look at it and say, wait a second, what type of question is that? Because we all know the truth that a pound is a pound. We've been taught that from the beginning of time, that a pound is a pound and therefore a pound is a pound. Therefore the question seems kind of bizarre. But what we've got to deal with is fact. Fact. A pound of feathers is 16 ounces. We all know that a pound is 16 ounces. Each ounce weighs 28.3495 grams. If you get 16 times 28.3495, you get a 453.592 grams, which is that value that we often learn when we want to learn how much is a pound. It's 454 grams. So we can make that conversion rather easily. So a pound of feathers weighs 454 grams. Fact. An ounce of gold, which is measured in the Troy system, is 31.10 grams. Wait a second, we just changed the value of an ounce, right? Not even an ounce is an ounce. No, they're two different weights. And there are 12 Troy ounces per Troy pound. 12 times 31.1 equals 373.2 grams. You can look this up in the Handbook of Chemistry and Physics. You can look this up on the web. And this is factual. Therefore, a pound of feathers weighs more than a pound of gold. So we have to be very careful about what we're looking at because scientists need to deal with fact. And this becomes very important when we make these decisions. Scientific method is a process. It requires you to be observant. You have to look around and you have to see what's going on around you. As you look around, you become inquisitive. You ask questions. Questions we often ask are who, what, when, where, how. Now that last one I put in there because people love to ask that question. But that's not really a good scientific question because if something is repeatable, we can learn the who, the what, the when, the where, the how of it. But the why of it, we don't always understand. And why comes down to a higher level of understanding. And therefore, in good scientific method, we don't always ask why questions. We ask who, what, when, where, how. And once we've got them down, we can kind of figure out our interpretation of why something happened, but it's not necessarily a why question. Second part says we formulate a hypothesis. Based on a definition, a hypothesis is a potential explanation for what you're investigating. So if you come up with a hypothesis, that's a potential explanation for what you've got. So you're coming up with this potential explanation. And then what scientific method says we're going to do is we're going to try and disprove your explanation. If you cannot disprove it, then the explanation holds. So you formulate a hypothesis. Next, we are going to conduct an experiment to test the hypothesis. And this is probably the trickiest part because anytime we're going to go out and we're going to test a hypothesis, we have to come up with an experiment that is going to look at it and test the hypothesis. Therefore, what we must do is we must control the variables. Too often we do science without controlling the variables, and if we do science without controlling the variables, then all of a sudden it's no good. So you have to be able to control the variables. When we look at things like global warming, one of the reasons global warming is so polemic is because we can't control all the variables because the scale is too big. It's not like we could separate some little part out and deal with that, but no, we have to be able to control the variables. And if you can't control the variables, you don't get a good science experiment. Scientific method, have to control the variables. Once we've done our hypothesis and we've conducted our experiment, and we collect our data and we analyze the data. When we analyze the data, it says we can have positive results, and positive results basically support the hypothesis that we've got. We also could have negative results, and negative results do not support the hypothesis. It doesn't necessarily mean that the hypothesis is wrong. The hypothesis may be inaccurate to a certain extent. It may need to be changed a little bit. It could be slap silly. When we look at it, negative results don't support the hypothesis. And then we've got non-results. And non-results say we've got a poorly conducted experiment. Poorly conducted experiment goes back to the concept we didn't control the variables. There are a lot of experiments and a lot of scientific material that you get nowadays that we go out there and we look at it and go, it's really a non-result because you didn't control the variables and therefore you really didn't test what you're trying to test. The scientific method becomes very important in this because you have to be able to deal with these properly. Then we get to make conclusions and we get to evaluate our hypothesis. When we evaluate the hypothesis, we may find that the hypothesis was correct. We may find that the hypothesis needs modification. We may find that we need to go back to the drawing board. What we're doing is we're trying to gather more information, be observant, and try to conduct this scientific experiment. Scientific method becomes this process by which we evaluate things.